Hello, everyone. My name is Zannettou, and I'm an assistant professor at TU Delft. Today, I'm going to present you our work on analyzing user engagement with TikTok's short-format video recommendations using data and donations. This is a joint work with colleagues from Max Planck Institute for Software Systems, University of Haifa, Georgetown University, and University of Washington. We are witnessing a significant shift in social media platforms. In the past, social media platforms mainly relied on user connections to create social media feeds. Think, for example, the early days of Twitter, where a user followed a bunch of other users, and then the platform created a set of tweets originated from the following accounts to be presented to the users. Nowadays, we are shifting towards AI recommendation systems to construct and deliver social media feeds to end users. Think, for example, TikTok, where a user is presented with an endless stream of video recommendations that are curated and ordered based on an algorithm. In addition to the use of recommendation algorithms, we are also witnessing a shift towards promoting and delivering content in the form of short format videos. So recommendation algorithms have several merits. First, they help users discover desirable content tailored to their interests. Also, recommendation algorithms help users to connect with like-minded individuals across the platform. The benefits of recommendation algorithms extend beyond content discovery and social connections. These systems are designed to captivate our attention, fostering deeper user engagement with the platform and its content. And what's the ripple effect of this engagement? It directly contributes to the platform's ultimate goal, which is to increase revenue. At the same time, recommendation algorithms have a darker side. Previous research, like the one by Ribeiro et al., provides evidence of recommendation algorithms potentially leading users down radicalization pipelines on YouTube. Also, previous journalistic efforts showed an alarming pattern of TikTok's recommendation algorithm, directing users towards information rabbit holes, in particular, content related to depression. Overall, there is a pressing need to analyze recommendation algorithms and understand how users engage with content recommended by algorithms. So in this work, we contribute to this need by focusing on the TikTok platform, aiming to analyze user engagement with the algorithmic recommendations and shed some light on the effectiveness of TikTok's recommendation algorithm. As we aim to explore video recommendations, we are faced with a pivotal challenge: data access. The question is, how do we obtain realistic traces of video recommendations? So previous studies have often used researcher-created accounts, also known as sock puppets, which are managed by automated bots. While this method is useful for data collection, it has several drawbacks when compared to data from real users. So these sock puppet accounts fall short in terms of authenticity, diversity, and history. Authenticity is crucial. The interactions from these accounts lack the organic quality of a real human user. Diversity is another aspect. These accounts cannot fully replicate the wide range of genuine user behavior. Lastly, history. These accounts do not possess the rich user interaction history that the real account accumulates over time. So the question here is, how do we overcome the challenge of obtaining realistic traces of video recommendations? So in this work, to overcome this challenge, we propose using a data and donation system. So based on the EU GDPR regulation, a user can request directly from the platform a copy of all the data that the platform has for them. On TikTok, for example, when a user makes such a request, he can obtain a detailed and rich dataset of the videos he watched, liked, shared, etc. So in this work, we designed and implemented a donation system for TikTok, recruited hundreds of users across the globe, and who used our platform to donate data for research purposes. Then we analyzed the dataset to understand user engagement. Now, let's dive into more details about our methods. Let's start with our data donation system. Our data donation system provides people with all the necessary information on how to use the TikTok mobile app to request and obtain their data from TikTok. After the users obtain their data, they can proceed with the donation. As the original dataset includes a lot of private information about the user, like date of birth, IP addresses, direct messages, etc., our donation system, by default, removes all personal information on the client side before transferring any data to our server. Next, the users can customize their dataset and select the specific fields that they want to donate. We implemented this feature as users may have varying comfort levels for specific parts of the dataset. For instance, users may not feel comfortable with donating their comments. At the end, after the users anonymize and customize their dataset, they can donate it with one click. Also, they are presented with an optional survey that allows us to obtain user demographics. So to recruit users to donate their data, we shared and advertised our study and donation platform on Twitter and Facebook. On Twitter, we posted a tweet that was amplified by all the authors of this paper, while for Facebook, we ran Facebook ads to promote our study. Overall, we recruited 347 TikTok users across the globe. We compensated our study participants with Amazon gift cards up to $20. So each participant requested their data from TikTok, and they obtained a detailed dataset of their activity. The dataset includes, for example, all videos that the user watched, videos that the user liked, comments that the user made on videos, accounts that they follow or follow the user, direct messages, etc. So one of the most important fields for our study is video viewing history, which includes the URLs of videos and the timestamps for each video that the user has watched. So all our recruited participants use our donation system to donate their data. Among other things, our dataset includes 9.2 million video views and 1.1 million likes. So since we aim to understand user engagement with videos, an important signal is how much time a user spent watching each video. Unfortunately, this information is not readily available to us from the TikTok dataset. Therefore, we need to perform inferences based on the timestamps. To do this, we first perform user session identification using the methodology from Halfager et al. Then, to infer the user viewing duration for each video, we simply subtract the timestamp of the next video from the previous one to figure out how much time a user spent on the previous video. We do this for all the videos in a session, except for the last video in each session. This is because the user takes a break and the inferred viewing duration will be unreasonably long. In the end, we end up with a dataset that includes our inferred duration for each video view. So in our pursuit of understanding user engagement with algorithmic recommendations on TikTok, we focus on three primary analysis signals. First, we have VOU, which is a measure of the number of videos watched per day by a user. Next is attention, which we'll calculate by taking the inferred view duration, dividing by the video's total duration, and then multiplying by 100 to get a percentage. This helps us answer questions like, did the user watch the video to completion, or did they scroll past it? Lastly, engagement is quantified by the number of videos a user has liked. This directly relates to the user's interaction with the content. Helps us answer questions like, did the TikTok user engage with a video by liking it? So this work studies the prevalence of these signals and observes how they change over time. Also, we are examining whether there are differences in these metrics for videos from accounts that the user follows versus those they don't. So let me show you some of the most interesting results from our analysis. We start by looking at how the volume signal, so how many videos are viewed daily per participant, changes over time in our dataset. We observe a notable upward trajectory in the mean and median number of videos viewed daily. Specifically, there is a twofold increase in the number of viewed videos after 80 days. So these results suggest that the recommendation algorithm is likely efficient in increasing the number of videos and the amount of time the user spent on the platform over time. So thus far, we show that users view a large number of videos and that the number increases over time. So the question that arises, though, is, do users watch videos until the end? So to answer this, we move to our findings related to the attention signal. Here I show you the cumulative distribution function representing the percentage of videos watched to a certain point. We observe that 55% of the videos are not watched till their end by TikTok participants, and that 40% of the videos are skipped without the user reaching their halfway mark. So looking at the user level results, we find that no TikTok user in our study watched more than 65% of their videos till the end, with most participants watching until the end between 30% and 50% of all their videos recommendations. So taken all together, these results indicate that the TikTok algorithm might not be that effective in making people watch till the end most of the videos. Next, we look into how the attention signal changes over time. One would expect that the percentage of videos watched until the end will increase over time when assuming that the recommendation algorithm is effective in inferring users' interest over time. Our results show that that's not the case. We observe that over time, the percentage of videos that are watched until the end is somewhat stable. Interestingly, we also find that TikTok users tend to watch until the end more videos that originate from accounts they do not follow rather than accounts they follow. Finally, we show how direct engagement with video recommendations via liking changes over time in our dataset. We observe that over time, users tend to like more videos, which likely indicates that the recommendation algorithm is effective in increasing this direct engagement signal. Also, in contrast with the results for the attention signal, we find that users tend to like more videos that are coming from accounts they follow rather than accounts they don't. So to summarize, in this paper, we undertake an empirical evaluation of user engagement with TikTok's short format video recommendations using data and donations. So the main takeaway points from our empirical evaluation are: so users tend to watch more videos on TikTok over time, hence spending more time on the platform. A large percentage of video recommendations are not watched until the end by TikTok users. Specifically, we found that 55% of the videos are skipped before their completion. Also, we found that user attention remains stable over time, while engagement via liking increases over time. So taken all together, it seems that the TikTok algorithm effectively increases users' watch time and engagement via liking, while overlooking the attention signal. That is, it does not increase the percentage of video recommendations that are watched till the end. Finally, our work demonstrates that data donations is a promising avenue for obtaining data from social media platforms in an era where many platforms are closing or heavily restricting their APIs. Make sure to check out our paper for lessons learned when designing a data and donation system and potential avenues for future work in designing and implementing data and donation systems. With this, I would like to conclude my presentation and thank you for your attention.